In this question, I'm going to do a longer kinematics question from the IB Math SL exam. So a kinematics question is about acceleration, velocity, displacement, and it's a calculus question because we use derivatives and integration to go between these functions. So it's always going to start with a particle P moves in a straight line. And that's the least important part of the question. Don't try drawing the straight line or drawing a vector or anything like that. It's a calculus question. We're going to deal with functions. So the particle is moving. Its acceleration is given as a function there in terms of t, which is like the third one in the chain of displacement, then velocity, then acceleration. So we would have to integrate to go back to any of the other functions for 0 to 5 for the time interval. And then they give us a specific point on the velocity function. So when time is 0, velocity is 3. So probably we're going to be asked to find a velocity function somewhere in this question. Indeed, if you look down at part C, that's what it's asking us to do. So part A says write down the values of t when a equals 0. So I might get a point for that, just writing the function set equal to 0. And ultimately, I'm trying to solve this for t. So because it's a calculator question, the most efficient way, especially if you're going to need it in part B, is to just have a graph of this and look for where it equals 0. Alternatively, you could try to solve this one without the calculator. It is factorable. So I'll factor it, and then I'll also go to the other slide and graph it. So if I have 3t and t, and I need to make a positive 8 but get a negative in the middle, I'm looking at something like this, seeing if that works. It doesn't seem to work. Try switching your 4 and 2. And you'll see this one does work. When you expand it, it's going to give you that original function. So you can see t is going to be 2/3. And t is going to equal 4. So these are the two times. Both of them are between 0 and 5. The two times when the acceleration is 0. Let's see what that looks like on the graph of this function. So 3t squared minus 14t plus 8. I'm going to go to a calculator, add a graph, and put in the function 3x squared, because the calculator thinks in terms of x and y on these axes, and then plus 8. Okay, so I can see a graph. I can see the two places where it crosses the x-axis. That one's 2/3 and that one's 4. If I was going to try to find them on the calculator, I would have to go to Analyze Graph and look for the zeros, because that's where it crosses the x-axis, is a 0. And then the next part of this question asked, hence or otherwise, find all possible values of t for which the velocity of p is decreasing. So this is where it's important to think a little bit about the relationship between a function and its derivative. So if you think about velocity as the function, then the derivative of it is acceleration, which is the one we have here. So velocity is going to be decreasing when its slope is negative, right? So the decreasing parts of functions are like when the slope is going negative. So the slope of velocity is acceleration. That's what derivatives mean. So the slope of velocity is acceleration. We care about where the slope is negative. So we basically just need to figure out where is our acceleration function negative. So if we look back at our graph, we can see it was negative between those 2 points we just found, right? The whole part of the acceleration function that's negative is down here between the x values of 2/3 and 4. So we're ready to just answer the question, as long as we express it correctly as an interval, that the velocity must be decreasing when time is between 2/3 and 4, and not equal to, because at the points 2/3 and 4, the velocity or the acceleration is equal to 0. It's not negative. All right, so that's A and B. And then in part C, we finally get to the 6-point question where we have to perform some calculus. We're finding an expression for the velocity of p, so we're going to have to integrate our function. So this is going to show up down here. The integral of 3t squared minus 14t plus 8. All of that gets a dt at the end. And this is an easy one to integrate because we can go term by term and they're all just powers, power rule. So we set up equals at the point where we integrate. Remember to increase the power by 1 and put it over the new power. So 3t to the third power over 3, which is just t cubed. 14t squared over 2, which is just minus 7t squared. 8 becomes 8t. And then there has to be a plus c at the end. And I can go back and put a v in front because this would be the function for velocity. And we have to go ahead and find the specific c value using the information given about the velocity function, that when time is 0, the velocity is equal to 3. So I should be able to set this equal to 3 and plug in 0 for t, and then I can see that if I plug in 0 for all those t's, I'm going to end up with 3 equals c. So now I know that the c value is 3. So there's my answer to part C. It's the expression for the velocity of this particle. And then find the total distance traveled by p, when its velocity is increasing. So distance is yet one more integral. If you have acceleration, you integrate it, you get velocity. If you have velocity and you integrate it, you get displacement. And the absolute value of displacement is distance. So we're going to have to integrate one more time. And we're also going to have to use boundaries on that integral. And the boundaries are going to have to be when the velocity is increasing. So we're going to have to go back up to the graph that we had on the calculator and look for where velocity would be increasing. So velocity is increasing when acceleration is positive, and that looks like before time 2/3, so from 0 to 2/3 seconds, and after 4 seconds, so between 4 and 5 seconds. So we're actually doing 2 definite integrals for this question, which is kind of fun. So we're going to have to set them up on our own, but then we can use the calculator to evaluate them. We're going to do the definite integral from 0 to 2/3 of this velocity function that we just found. And remember to put absolute value around it when you're using the calculator to evaluate a numeric integral, plus 8t plus 3. And plus, because we want to know the total distance traveled by p when its velocity is increasing, 4 to 5, and it's the same function in absolute value. So we could evaluate these 2 separate numeric integrals using the calculator by going to a calculator screen, so not a graph screen, but a calculator screen. I have myself a calculator. And on this menu, we have a few options under calculus, including numerical integral. So we're going to be going from 0 to 2/3 and evaluating the function. And I think I'm not going to finish it, but then we can do plus. And again, we can go to the menu, calculus, numerical integral, and do 4/5, the same thing. And then we'll type in the function and dt. If you're going to use t, then put this as dt. If you're going to use x, then put this as dx. Type in the function, hit enter, and it will evaluate this and add it together for you, which is going to be the answer to the question, total distance traveled. And that is all.